Hello, my name is Orlando Castilleja. Today we're going to model a piping system using COMSOL Multiphysics. The main objectives that we want to achieve with this simulation is to sketch a basic geometry in COMSOL Multiphysics. We also want to specify the inlet and outlet boundary conditions for this model. And at the end of this tutorial, we're going to retrieve the flow parameters, for example, the pressure and the velocity from the entire data set that we are going to be calculating. The main problem is to consider a pipe network similar to the one that we have in this image, and we want to assume that the diameter of the pipe is 3 inch and the volumetric flow rate is specified as 0.013 cubic meters per second. We want to achieve some specific objectives, and these are to calculate what are the velocities at the inlet and the outlet of the pipe. We also want to determine what is the pressure at the inlet of the pipe and what will be the pressure drop in this section of pipe. Okay, the geometry that we are going to draw in this case is this one that we have in the image, and we are going to be specifying these segments. We are considering that the bends are smooth bends of 90 degrees. Here are again the lengths for every section of the pipe, and at the end we are going to be obtaining some visualization like this one, where we can visualize the relative velocity or the velocities that we have inside in this domain. In this case, we are modeling the flow of water. Okay, let's move to the software, COMSOL Multiphysics. In this case, I already opened the software, and the first thing that you are going to see is this window. Okay, in this window, you are going to be able to select whether model wizard or blank model. If you click blank model, you are going to have to define everything from scratch. And if you use the model wizard, it's like you have an assistant that is going to help you to specify the first steps for this model. So I'm going to click model wizard, and then you have to specify the space dimension for your simulation. In this case, we're going to use a 3D model, a 3D geometry, and we're going to look here in fluid flow. If you have available the fluid flow different physics, you can select the single phase flow, and you're going to select turbulent flow, and later you can select k-epsilon turbulent flow. Of course, if you know that your system is behaving as a laminar flow, you can select laminar flow, but you have to determine the Reynolds number in order to know whether you are dealing with laminar flow or turbulent flow. So I'm going to select turbulent flow k-epsilon. I'm going to click add, and you're going to see here the variables or the dependent variable for your problem. You are going to click study, and here in this window you are going to select the type of study that you are performing. If it is time dependent, you can select time dependent, but you will have to select a range of time in which you are going to be performing your calculations. We're going to select, in this case, stationary, and I'm going to click done. Okay, it's a steady state problem. Okay, in this window you are going to have like 4 main sections. In this section you're going to have the model builder. The model builder is going to be like a tree in which you are going to be defining your CFD model. In the window for settings is where you are going to be specifying some boundary conditions, some geometry characteristics or features, mesh features, etc. And in the graphics window, you are going to be observing or visualizing the results that you have, the geometry that you are specifying, the mesh that is being generated, etc. In this part here, you're going to have the main tools, the toolbar, and here you can be defining the geometry. You can specify the material that you are dealing with, the physics or the models that you are going to be considering in your simulation, the mesh, etc. and I'm missing something here, and this is the well, this is like a log or a, well, where you can visualize some messages from the simulator, from the software COMSOL Multiphysics. Okay, here you can visualize some results that you are calculating, the log, the progress, that is what is happening with the simulation when you are making your, you are doing your calculations, etc. Okay, let's begin with the model builder. We're going to specify the geometry, and here you are going to have this node that is called geometry 1. In geometry 1, you can right click on it and you are going to see different options. For example, these 3D shapes, or if you don't want to do this, you can go always to the toolbar and you're going to see geometry. And here you're going to have almost the same buttons or options. Okay, so for example, I'm going to draw, well, I'm going to select, I'm going to geometry 1 and I'm going to select work plane. So I'm going to be working on a 2D plane, and I'm going to specify it in the plane XY plane. Okay, I'm going to select plane geometry, and here you can see this canvas, so you are going to start drawing here. But here is a little bit different to other software like SolidWorks. You are going to have to specify some parameters instead of directly drawing in this canvas or this workspace. I'm going to go here to plane geometry, and I'm going to right click on it, and I'm going to select line segment. Okay, so in this line segment you are going to be specifying the different parameters for these lines or these geometries. Okay, for example, the first one, you have to specify what is the starting point and the end point for this line, and I'm going to specify that the starting point is 0, 0. Okay, and you are going to change here. It is by default in vertex, but you're going to define the coordinates. Okay, you're going to select that the first point is located at 0, 0. The end point, in this case, I'm also going to select coordinates, and in coordinates you are going to type 1, 0. Okay, this is going to specify or to draw a line that is 1 meter length, starting from the origin of this plane. Okay, you are going to click build all, or you can click build selected, and you are going to see this line. Okay, for the next step you are going to add a curve or a bend. In this case, I'm going to right click on it on plane geometry, and I'm going to select circular arc. Okay, in circular arc I'm going to define that the radius for this arc is going to be 2 inch. Okay, in radius I'm going to type 2 inch. As you can see here, it is expecting that you specify meters, but if you know other the value with other units, you can only type 2 and the units in brackets. Okay, the center for this circular arc is going to be 1, and here is going to be -2 inch. Okay, and the angles is going to start at 0 and is going to end at 90 degrees. And build all, and now you can see that you have this arc here. Okay, this is going to produce a smooth bend in this corner. Okay, right, next you have to draw a different section of pipe, and I'm going to select in plane geometry, right click on it, and line segment. Okay, in line segment you are going to be able to select the starting point, this point here. So you can select specify vertex, start vertex. You are going to click here to activate this box, and you are going to be able to directly select this starting point. Okay, but now you have to specify the coordinates for the endpoint, and in this case the endpoint is going to be located at 1.0508 meters. Okay, I'm going to specify meters in brackets, and later the y is the point is going to be specified at y minus 1.0508 meters as well. And yeah, now you can build all. Okay, I'm going to click here in order to zoom out, and now you have this section that is 1 meter and 1 meter with this small bend here that is 2 inch in radius. Now I'm going to specify a second circular arc, and this second circular arc is going to have a radius of 2 inch as well, and the center for this circular arc is going to be specified at 1 meter and minus 1.0508 meters. Build all. Okay, I think that I have to change here the angles, and the angles are going to be minus 90 for the starting angle, and to the end angle 0. Okay, now you can see this. Okay, now the third line is going to be starting from this point, and is going to be finishing at a given coordinate, and the coordinates are going to be minus 1, and for y it's going to be minus 1.1026, and there you go. This line is going to be about 2 meters. Okay, and now we have to generate a circular arc here, circular arc, and in this case I'm going to have, I think that is minus 1, and here is minus 1.0508 meters, and here is going to be 2 inch, and the starting angle is going to be 270, and the end angle is going to be 180. Okay, I'm going to click clockwise. Okay, in this case you are going to select clockwise, and you are going to specify these values for the start angle and the end angle. Okay, next I'm going to specify a line. It's going to be in geometry, line segment. I'm going to start from here, and in this case this is a 4 segment, and this segment is going to be coordinates okay, I think that I'm not writing right. This is okay. These are the right parameters. Okay, minus 1.0508 in x, and in y is going to be 1 meter. Okay, next okay, I'm going to create a circular arc. This is going to be minus 1 meter. Here is going to be 1 meter, and here is going to be 2 inch build. And I have to change the start angle. It's going to be 90 and 180. Okay, and later I'm going to select line segment. I'm going to start from here, and here is going to be coordinates. Here is 1.5 meters and 1.0508. Okay, there you go. And finally you have to draw a final line that is going to be 2.5 meters, and it's going to have as well circular arc. This circular arc is going to be 1.5 meters, and here is going to be 1 meter, and here is going to be 2 inch. Build all, and that's okay. And finally I'm going to draw a line segment that is starting from here, and the end point is going to be coordinates, and the coordinate for this line is going to be 1.5 inch and 360. Okay, this is okay, these are the right values. I mean, x is 1.5508 meters, and the coordinates are for y are minus 1.5. Okay, now you have this sketch. It's a 2D sketch, but we want to generate a 3D object, and we are going to generate a circular pipe. So to specify the circle, we are going to create another work plane, and this work plane is going to be generated here. Geometry 1, work plane, and in plane geometry you're going to draw a circle, but you have to specify that you want this plane to be generated in CY. Okay, you are going to be changing here in work plane 2. You are going to locate the plane definition section, and you are going to locate the plane list, and you are going to change for YC plane, that is this one. I'm going to click here, show work plane, and it's something like this. Okay. Okay, the plane is going to be here. So I will need to generate in this plane a circle. I'm going to click circle, and the radius for this circle is going to be 1.5 inch. Okay, and it's going to begin from the center, that is 0, 0. So it will be something like here. I'm going to build all, and there you go. If you come back to this plane, work plane 1 or work plane 2, and I click build all objects, you are going to see how the plane is located and where the circle is located. And if you can see here, the circle is located at the beginning of the curve. Okay, so we have to extrude this circular shape along this curve or this line. Okay, so what we are going to do next is to go to extrude in the geometry ribbon, and we're going to select here extrude. And in extrude, it's not extrude. I'm going to delete here. Yes, I'm going to select sweep. It's sweep. Here you're going to have two different options. The faces to sweep that are going to be this circle. I'm going to select this circle here, and the spine curve. The curve along you are going to be sweeping this or extruding this circle. So I'm going to deactivate this one, and I'm going to activate this checkbox, and I'm going to be selecting the lines or the curves that are going to be covered by this circle. Okay, all of these curves has to be, and I'm going to select, I think that I have to select reverse direction. I'm going to build objects. Okay, there's no need to reverse direction here. You just are going to click build all objects, and there you go. Okay, now you have this geometry, and now you can start specifying your CFD model. Okay, before specifying the model, I'm going to mesh before anything, and I'm going to visualize what is going to be the mesh for this case. Here we have by default the normal element size for the physics control mesh. It is going to determine for this specific physics the appropriate mesh that we're going to have, and build alt. Okay, the generation of the mesh can take a little bit long, but it's going to depend on your computer and your computational resources. Here I think that is enough with this for this example, but you may be willing to change in order to refine or make it coarser according to your computer or your demandings. Okay, I think this is enough, and I'm moving to the turbulent flow physics in order to start specifying the model. I'm going to specify the materials, and you're going to have this node materials. In materials, you are going to right click on this node and add materials from library, and I'm going to look for liquid water, and liquid water here it is, and I'm going to add to component. Okay, now you can see that it's going to be applying in all of the domains that we just draw, and all of the material properties are already given here, so we don't have any problem with the properties. We have this node that is called turbulent flow, and is regarding the model that you have or that you want to simulate. If you don't want to work with this turbulent model that is k-epsilon, you can change it, for example, to k-omega or something like that. And for example, if you know that your system is behaving like a laminar flow, you can change the model. For example, you're going to click node in turbulence model, and automatically it's going to be changed to laminar flow. Right, I'm going to go back to RANS, to RANS, turbulent flow, and here we have k-epsilon. So if you want to know what is the equation that is going to be solved in this model, you're going to expand this tab equation, and you will see here the equation. Okay, here in this is for stationary state, and here you can select whether you are dealing with compressible flow or incompressible flow. In this case, we are going to be dealing with water, and we can select that is an incompressible flow, and we're going to include the gravity. The reference pressure is going to be the atmospheric pressure. The reference temperature is going to be 293, and I think that's all for this node. I'm moving to the fluid properties node, and you can see also that reference temperature. You are going to see that the fluid properties I'm going to be drag or are going to be considered from the material that we already defined. But if you want to change them, you, for example, can define user-defined properties here. Initial values. Initial values is telling you that the velocity profile is 0 in all of the components. Okay, and here you have some by default, some default values for the for the turbulence model. Gravity is going to be considered because I activated here, and I'm going to start specifying the boundary conditions. In this case, we will need two boundary conditions that are going to be the inlet boundary condition, and I'm going to right click here, turbulent flow, and you're going to specify to select or look for inlet. If you don't want to do this, you can do it by the ribbons here, and you're going to go to physics and boundaries, and here you can find the inlet, the outlet here, inlet outlet. So inlet node, you can change from here to the mass flow, and the mass flow type you're going to select I mean it's going to be fully developed flow, and flow rate, because we know the flow rate, and the flow rate is given in the slides, and we know that the flow rate is 0.013 cubic meters per second. Okay, and this is going to be the volumetric flow rate at the inlet surface. I have to select this surface. This is going to be the inlet boundary, and that's all. Now for the outlet or the pressure, I'm going to right click on turbulent flow, I'm going to select outlet, and I'm going to select the outlet in this case. And you don't have to do anything because you are specifying that the manometric pressure there is going to be 0, that is the atmospheric pressure. Okay, and I think that's all. The walls are already defined, and the conditions for the walls are the no slip boundary condition. Okay, of course you can select here whether it is no slip or slip. I'm going to select no slip boundary condition. If you know the roughness for this material, you can select the roughness, and you can specify it as well. I'm not going to say that you have some roughness in this pipe, so I'm going to leave it that way. And I think that's all. Now you can start running the simulation, but in this case I think that is going to take about 30 minutes depending on your computational resources. And for this case I run a model that we already specified, and the time that it took to model this, to simulate this, was about 30 minutes. So you better be prepared for this. I think you must know that this is a very simple model. This is a very simple 3D geometry, and still took like 30 minutes to run in this case. And this is because of the computational model that you have, or the simulation model that you have, because the turbulence model are very computational demanding. And of course, if you are modeling a 3D geometry, it's going to take longer, longer than if you specified a 2D model. Okay, so you can go to stationary, step 1, stationary node, and compute. Okay, now you just have to wait for it to run and to complete the calculations. Okay, if you can see here in the messages, it's going to tell you how many elements are you going to be dividing your computational domain into. For example, here in this model we have like 500,000 domain elements. Okay, that's too much. And in progress, you can see the progress of your computation for the results. Okay, we don't have anything here. And convergence plot, you are going to visualize the convergence error and the convergence plot too. Okay, here still we don't have anything yet, but they are going to be appearing later. this is the error for the velocity and the turbulence parameters. Okay, once you finish, once the solver finishes the calculation, you are going to visualize something like this. And for example, this is plotting the velocity magnitude with some cut plots here, and if you zoom in here, you're going to see these colors. Okay, that is telling you that the velocity near the walls is almost is lower, and the velocity in the center of the pipe is about 3 meters per second. Okay, if you want to generate some other visualization or in figures, you can go here to the part of results, and you are going to right click on results and select 3D plot group. This is going to generate a 3D object or 3D plot. I'm going to right click on it, and I'm going to select isosurface. And isosurface is going to be generating some surfaces inside the pipe domain. For example, I want to plot the velocity value, and I'm going to define a total of 10 levels. Okay, and the color table is going to be rainbow and plot. Okay, now you can see this. This is telling you that the blue colors are going to be the lower values, and the hot colors, the warm colors, are going to be the higher values for the velocity. And if I zoom in here, I can visualize this. And if you want to increase the number of surfaces, you can increase the number here to 20. Okay, now you can see this. And this is the inlet. At the outlet, we're going to have something like this. And in the corners or the bends, we're going to have a very, very high velocity in this part, but we're going to have a lower velocity in this side. Okay, and after the bend, you're going to see that in this case we're going to have a lower velocity. Okay, lower velocity, higher velocity. Okay, there you have. Okay, now if you want to retrieve some specific flow parameters, for example in the inlet or the outlet, the velocity, the pressure, the mass flow rate, the volumetric flow rate, you're going to go here to derived values. I already have some derived values, but I'm going to show you how you can obtain these values here. Derived values, right click on derived values, and you're going to select average list. From the average list, you can select surface average, and this means that you're going to be calculating an average value on a given surface. And you have to select the surface on which you want to calculate the parameter, that is going to be the inlet in this case. And you can look for the different variables that you have available to calculate. For example, you're going to click here, replace expression, and you're going to have turbulent flow k-epsilon. And in velocity and pressure, you're going to look for the velocity magnitude, that is SPF point U in meters per second. Okay, you're going to select it, and I'm going to delete this table, and I'm going to click evaluate. And you are going to know that this is 2.9254, I mean. And this is the velocity in this phase. And we expect that the velocity is going to be the same on the other outlet, the other boundary condition, because the area is not changing along this pipe network. So I'm going to right click on here and derived values. I'm going to click average, surface airbrush, and I'm going to click here in this zone, in this face, and you're going to select turbulent flow, velocity and pressure, and SPF, velocity magnitude. Okay, evaluate. Okay, I think that it is actually changing. No, it is okay. I think it's okay. Okay, the value is very similar. Okay, for the calculation of the pressure, I'm going to go to derive values, average, surface parameters, and we already know what is the pressure here because it's the atmospheric pressure, but we want to calculate what is the pressure in this zone, in this phase. So I'm going to click in this boundary, and I'm going to look for the pressure, turbulent flow, velocity and pressure, and evaluate. And here we have this value for the pressure. For the other phase, I'm going to select average, surface average, and here I'm going to click here, and I'm going to write P and evaluate. Okay, here you have this pressure here. And if you want to calculate what is the pressure drop, you're going to calculate the difference between these values. Okay. Okay, these are other predefined plot for your simulation, for your results, and here is the pressure contours. Okay, how the pressure is changing along this pipe network. Of course, you're going to have the higher pressure here and the lower pressure in these sides. If you want to increase the number of contours, you can specify it here. Okay, I think that this is all for this simulation and this tutorial. I expect that this is useful for you and that you can apply it in all of your projects. I expect that you keep safe. See you later.